You are listening to 95.7 FM WELT, Fort Wayne, Radioactive. The opinions and views expressed in the show are those of the hosts and guests only. They do not represent those of FreeThought Fort Wayne, WELT, or any other organization. Welcome to the Hoosier Humanist Hour, where we explore science, religion, culture, ethics, and community from the humanist perspective. Join us as we discuss those topics and more, free from the ideologies of religion and superstition.
Good evening, and thank you for joining us for another episode of the Hoosier Humanist Hour. The Hoosier Humanist Hour is a show dedicated to discussions on all things humanism, or really just about anything, so long as we could discuss it from the humanist perspective. The Hoosier Humanist Hour is a 501(c) nonprofit educational program brought to you by volunteers from FreeThought Fort Wayne in affiliation with the American Humanist Association. My name is Caleb. I'm joined today with Chris, V, and Andrew. And today we get to talk about the end of time, the end of the universe. How will it all go out? That's basically the question we're asking tonight. How does the universe end? Is it a fiery brimstone thing? Who knows? But I honestly think, personally, I'll just say right off the bat before we jump into it, I honestly think that we're going to end up going into a big freeze. That's kind of my best guess at the moment. But we'll get into what that means in a little bit. I thought that, not just me, excuse me. I don't want to take all the credit. We thought that it would be good to go ahead and continue the conversation that we had last week. We attempted to cover the universe beginning to end. We soon discovered that was impossible in an hour. It just wasn't going to happen. That was poorly executed. But we basically covered our thoughts on how the universe began. So we thought, let's just do an episode on how we think the universe is going to go out. Is it going to go out with a bang, a crunch, a rip, big freeze? Are we just going to flash out of existence? Is God going to start over and create a whole new universe? I don't know. And the best place to begin, I think, would be to go with whatever is the best scientific consensus thus far, like whichever one's really up there. Anyone have any idea which scientific theory seems to hold the most merit?
Well, I myself subscribe to the big rip idea. So there's really three major scenarios, I believe, that scientists are considering. So there's the big crunch, the big freeze, and the big rip. Caleb, you went over some of those. So the big rip, which I think is going to be kind of the end of the universe, is basically a case where, the universe is going to keep expanding the way it is today. That expansion is going to keep accelerating. And basically what's going to happen is galaxies are going to start to fly farther and farther apart. Eventually, they'll be flying apart at a speed that's faster than light. So we're not going to be able to see any other galaxies. Then the space within the galaxies is going to start to stretch as well, to the point where even nearby stars are going to fly apart. And then, things are just going to keep flying apart, to the point where even atoms will fly apart. Even atoms will not be able to stay together. So, that's kind of the big rip, a whole lot of nothingness coming our way.
I agree. I think that's pretty likely. However, I want to talk about something that you had mentioned. You said that at some point, the galaxies will be moving away from us faster than light. Is that correct?
Yes.
Just for our viewers, can you kind of explain how that's possible? Because we already know that nothing can travel faster than the speed of light.
Right. Well, so technically, things that are made of matter, things that have mass, can move at the speed of light or faster relative to other things that are made of just regular matter, particles, whatever. But there's nothing that prohibits space from expanding at a rate that will be perceived by an observer to be faster than the speed of light. We actually think that happened at the beginning of the universe. So right at the moment of the Big Bang, something called inflation is supposed to have happened, which I believe at that time, the universe expanded by some 90 orders of magnitude in a really small amount of time. And so space at that time would have been expanding faster than the speed of light. And currently scientists look at stars and galaxies that are very far away from us, and we can measure in various ways how fast these things are moving, and if they're coming towards us or away from us. And at first, scientists noticed that everything's moving away from us, and they thought that it surely, everything that's moving away from us must be slowing down as it's moving away, because gravity was pulling everything together. But then more precise measurements were made, and they figured out that everything that's moving away from us, like other galaxies, especially ones that are really far away from us, are actually moving at an accelerating rate. When I say far away from us, for example, Andromeda galaxy is 2.5 million light years away from us. That's actually coming for us. So that's close enough to where the gravity of the two galaxies is going to make those two galaxies collide eventually. But things that are far, like billions of light years away from us, are actually moving away at an accelerating rate. And we think that that expansion is going to continue to accelerate, and that's actually due to space being created or stretched between us and those other galaxies. So that's how eventually they can move faster than the speed of light, if my understanding is at all even remotely correct, which it may not be. This stuff is pretty complicated when you read about it.
Sure. I mean, the way that I understand it is to summarize it by saying that the rules that apply to a part of the thing might not necessarily apply to the whole thing. The go-to example here is, every sheep in a flock has a mother, but, the flock itself doesn't have a mother. So when we think about the speed of light and how eventually we predict that the other galaxies will be moving further away from us faster than the speed of light, essentially what they're saying is that although information within the universe cannot travel faster than the speed of light, the universe itself is not necessarily bound by that same rule. So the universe could potentially expand faster than the speed of light. And we actually have evidence to suggest that this at least happened once, as you were talking about with this inflation deal. That's extremely important. I think that goes a long way to showing that this sort of hypothesis is likely to be true. I mean, it's just evidence that it's at least possible. You were saying that they predicted originally that the universe would eventually collapse in on itself because of all the gravity.
Right, all
right. So let's see here, pop quiz. Do you know then why we no longer believe that?
Well, so our understanding of the universe has changed over time, right? Initially, when Einstein first came up with his theory of relativity, special general relativity, people thought that the universe was just going to be static. And Einstein had to add this cosmological constant to his equations to make sure that when he applies his equation to the entire universe, which at that time was only the Milky Way, they didn't even know there were other galaxies, had to add those weird cosmological constants to stabilize the universe and make it static. So people thought that, the universe was static, it was eternal, all this. Then we made measurements and we figured out that, oh no, it's not static. Oh wait, there are other galaxies. And, more recently, we found weird things like dark matter and dark energy. And, both of these are, to a large extent, unknown. We can see their effects, and that's how we infer that, both dark matter and dark energy exist. But what they're made of, how they came to be, and what their true nature is not really well understood. And it actually seems to be that dark energy is what dominates the universe, is causing this expansion.
So what you're saying there is that we can measure the thing, but we don't actually know what the thing is.
Right.
Okay.
So it turns out, just to throw out some numbers, as best as we can measure today, the regular matter that we're all familiar with, the stuff that we're made out of, like protons and neutrons and electrons and other particles, that's only 4% of the observable universe.
Wow.
Yeah, it's really just a little bit of cosmic pollution, as some people have referred to it. So it seems like dark matter is about 23%, and the rest, about 73%, is dark energy. So we really don't know what 96% of the universe is made out of, which is kind of crazy.
Or how it works, or how to even figure out, what it is in the first place. I mean, it's just, I love this. This is one of my favorite things in the world to talk about, because nobody really knows what dark matter is, and it could be just about anything. I've heard some people speculate that it could be like gravitational influence from other dimensions, like alternate universes and such. I mean, I've heard some really out there theories about what dark matter and dark energy might be. And I don't know. I honestly still haven't heard anything remotely convincing, at least not more convincing than any other decent dark energy or dark matter theory. What about you, Chris? Do you have any thoughts on dark matter and dark energy in particular?
I just think it's the word to use when we don't know. Just like God has frequently been the word to use when you don't know something. And you know what? It's okay not knowing something and admitting that you don't know something, because we will eventually find out what that something is. That is what history has taught us, and that's what the future teaches us. So to ascribe the terms dark matter and dark energy to things, those two words are describing less and less every day as we find out more and more about the universe and the types of things and types of physics that govern the universe. So it's honestly, this is the last frontier, and that's why we say that space is the final frontier, because this is our last area of study to complete our knowledge. We know and understand more than 96% of everything else. Space is the final frontier.
I absolutely agree. I think that space, ultimately, whatever's out there, is going to change us in the grand scheme of things, is going to force us to change in the grand scheme of things far more than anything on this little rock. And I think that once we get out there, find it, figure out a way to use it, whatever it is, I honestly don't know. I mean, who knows? It's just one of those big what ifs that I like to kind of sit there and think about around the campfire. But the physics of the thing, really interesting and really important as well. For the longest time, in order to explain these things, we just kind of had to speculate. That's how a lot of these, I believe the word is eschatological. This is the study of the end of times in a religious context. So these people would make up all kinds of, like Ragnarok, for example. They think that eventually the universe will end when all the gods are defeated and there's this eternal winter, which is, in my opinion, kind of eerily similar to what I think is most likely. I do think that eventually everything will just kind of expand out and everything will be at, I believe it's maximum entropy. I could be completely wrong and it's minimum entropy, but at that point, they'll just essentially be nothing. And furthermore, I think that it's also possible that all particles within the universe, even if they're fundamental particles, I think at some point, even those will decay into nothing, eventually go back into the Higgs field and cease to be anything but virtual particle potential energy. And I think that really that might be one of the reasons. This is just pure speculation on my part, but I think that the death of universes is what gives room and rise to new universes. That's just a guess. It's just a hunch. Some scientific evidence suggests that everything in the universe has some sort of decay rate. So obviously some things have faster decay rates than others, but once you start getting down to like electrons, for example, or neutrons, better yet, those decay rates are extremely long. Some predict upwards of like 300 trillion years or something like that, or 300 trillion times, some ridiculous number. Because, well, actually, that's actually a good place to stop, kind of hit the brakes. Anyone here pondered to presume, guess, speculate as to how old this universe might get before we consider it no longer a universe?
I honestly feel like the biggest problem with all these different end scenarios for the universe is understanding the mathematical graph that is produced from the numbers that we are studying. That is to say, if the graph is an exponential graph, one in which we see the universe expanding at a continual exponential rate, well, then that obviously argues for a much shorter lifespan of the universe. If the universe has more of a bell curve, however, well, that actually is more in favor of the big freeze, to where the expansion of the universe will increase to a certain degree, but then it will teeter off, it will plateau, and then it will start crunching. And that will result in the big crunch. And then in the big freeze, of course, big freeze kind of assumes something more either exponential or a plateau where the universe accelerates in its expansion until it reaches a certain point. So it certainly could increase exponentially or geometrically to a certain point, and then plateau at that point where all particles have basically expended all their energy, and that's why we call it the big freeze. Now, of course, the big rip favors more of a true exponential scenario where particles continue going apart without any sort of plateau, and that's why we see all matter, space, and time ripping apart, even at the elementary particle level.
So let me throw some numbers out there, guys. I think maybe a little bit interesting for our listeners, just to give a little bit of a time scale as to what we're talking about here. So our sun that we orbit is going to burn out in about 5 billion years. So, the sun's going to swell up. I think eventually it'll reach the orbit of Jupiter, but it'll certainly engulf Earth as it's burning out and it's becoming a red giant and all that. But then in about, I believe, I was listening to a Q&A with Lawrence Krauss. He was saying that if the universe continues to expand as it is today in this accelerating way, in about 1 trillion years, you won't be able to see any other galaxies outside of the Milky Way. And I think it was Sean Carroll in a completely separate interview was saying that about 1 quadrillion years from now, the last stars will burn out in the universe. So we still have a lot of time, until we reach those far off scenarios.
It's funny that you mentioned that because I'd completely forgotten about that. I remember hearing a debate. I can't honestly remember who it was with, but it was just is God more likely than not kind of debates. And this guy was trying to argue for intelligent design. This universe is more designed for the existence of black holes than for life. Because black holes are going to exist and practically and most likely be the only real things that exist. Black holes and maybe some like neutron stars or some really intense stars. Those are going to be the last things that ever exist. The universe will be dark in every direction, and the last thing there will be the black hole. So to say that the universe is fine-tuned for life is kind of absurd, because as you were just saying, in 1 trillion years, Krauss would say that those people would have no way of really knowing whether or not the universe had a beginning. The background, the cosmic microwave background radiation will have dissolved essentially to the extent where it won't be indistinguishable from the rest of the universe. So they'll just stare off into an empty nothing, with no way to distinguish the fact that their universe is expanding or not. So as far as they're concerned, they'll be looking out as the only galaxy in an eternal static universe. So that universe that Einstein predicted, or wanted to predict, that he was looking for, that static universe, they would have every reason to believe that. And I think this is another one of those things that I think it's wonderful that Lawrence Krauss likes to preach. I mean, he practically preaches this stuff every time he's on stage or in front of an audience. True. I think it's beautiful stuff, and I don't want to get sidetracked though. So
no, I mean Krauss is a great lecturer. I mean, he's a true scientist that wants to educate people, and this is the kind of stuff that people ask him. So this is the kind of stuff that he talks about, but he doesn't really preach it though. I mean, preaching implies some dogma, and there's a lot of baggage with the word preaching. He teaches. I don't know. I may have misheard you, but I thought you used the word preach, and
no,
really,
I definitely said preach.
I'm a little bit allergic to the word in scientific context.
Well, sure. I mean, that's fair. I agree. I didn't mean to make it seem like he was proselytizing this
I know,
idea as dogmatic truth. And in fact, he's one of those people who will tell you that he can't dogmatically tell you anything is true, that you can only be so certain, and that certainty is not 100% for anything.
Right.
And that's one thing that I respect. And anyway, so on this, sorry, okay, let's backtrack here. So back on the black hole kick, you were talking, okay, so we're at a trillion years from now, these people are going to be looking out into this static universe type realm. Well, the world that I'm talking about, where it's black holes and maybe a handful of special type stars, that's like something along the lines of 300 trillion years.
Yeah, probably.
And that figure is so astronomically huge to think about. It's kind of, honestly, it's mind-boggling. I kind of find myself thinking about that all the time, because I think about my mortality a lot. I don't know, that's just me, and I kind of wonder about an eternity and how the universe is going to fare without me. Which it's gonna fare just fine, but I'm curious how that process is gonna go. These are those big mysteries that, unfortunately, I doubt that we'll ever really get the answers to. Personally, maybe somebody somewhere, at some point may, but I think honestly, I'm going to the grave not knowing this one.
The universe. I hate to say this, but the universe got along just fine for the last 13.7 billion years ago, before any one of us was around to do anything about it, and we were way too insignificant to affect anything in any meaningful way. So
yeah. Oh, and I'm glad you brought that point up. I was having a conversation the other day with a buddy of mine, and he loves to just ask questions about science and this, that, and the other. I was trying to explain to him that the universe that we live in is relatively young. I mean, it's very young when you think about how old we predict it's gonna be on average. I mean, most prediction models anyway. And the one that I adhere to in particular is approximately 300 trillion years, plus or minus 50 or whatever. But just put that into scope. I mean, we're 13.72 billion years old, and the universe is going to live for hundreds of trillions of years. Our universe is a little baby. It's still its cradle phase, and that's why I think it's really interesting how you kind of see the universe hit its midlife crisis right around that trillion year mark, but that's nowhere near the end of its lifetime. It's just the way that I see it.
Let me just throw in something else interesting that is very much relevant to just what we were talking about until this point. So I was listening to an interview with Dr. Michio Kaku. I'm sure everybody's heard of him. He's a very popular figure, likes to give lots of interviews and lectures and all that. And he likes to imagine how, what's going to happen in the future and give predictions and stuff like that. So one thing that he was talking about, at these trillion-year scales and hundreds of trillions of years, obviously the universe will become very inhospitable to intelligent life. I mean, we're talking about heat deaths, everything reaching absolute zero or ripping apart, and dark energy just blowing everything away. All these kind of very, very dark scenarios. But one thing that Michio Kaku was talking about was, well, imagine, let's say, nothing like us people, like what we look like today, would exist in a trillion years. But, if some intelligent life or civilization keeps learning on that kind of trillion-year scale, he was suggesting that eventually we may be able to learn how to manipulate space and time in ways that, we can almost create our own new universe that would still be hospitable to intelligent life, or like create our own little corner that would be hospitable to intelligent life. I don't know if he meant forever, or at least for a while longer. And, what he was talking about in that case was what's called a type 3 or a type 4 civilization. So these are civilizations basically that operate on galactic and universe scales. So they could harness lots and lots of energy from entire galaxies and therefore be able to manipulate the universe on these kind of large scales. But currently, we're not even a type 1 civilization. A type 1 would be a civilization that can manipulate their nearby stars. And, we really can't manipulate the sun. We're just now figuring out how to use the sun energy directly. So we're not quite a type 1 civilization yet. So I thought that was kind of an interesting view, that you may be able to gain enough knowledge and have enough understanding of the laws of the universe and all that you could potentially manipulate space-time around you to preserve it for intelligent life for way longer than our current understanding would suggest. That's possible.
Interesting. So honestly, that almost sounds like you're talking about creating little personalized pocket universes. Is that about right? I mean,
that's kind of how I was understanding him to mean. I mean, he referred to this as escaping the universe, but I think what he meant was just kind of creating our own section that we can inhabit happily and still have intelligent life for
that makes
much longer.
That makes a lot more sense than the way that I had understood him. Because honestly, what you just said there, the escaping the universe, when he was saying that, I kind of always pictured going to a different universe altogether. That's how I always kind of understood him when he was saying that. But I like that better, actually, because that actually seems much more reasonable. Instead of creating a whole universe or going to a whole universe, you just manipulate the one you have and create your own little quarantine zone, if you will. I mean, think about that. Wow, if you could manipulate, that'd be really fascinating.
Yeah, I mean, one cool thing to think about, I mean, there may already be, these kind of weird pockets of universes that we could never communicate with. And that comes out of kind of what I mentioned earlier. When the universe began with the Big Bang, there was this period of inflation, right, where space expanded faster than the speed of light. So if that's true, then there are regions of space that couldn't have communicated with each other. So because light couldn't have traveled there between those two regions, so no information could have traveled, because information travels at the speed of light. If things expanded faster, then they couldn't have communicated, which would mean that potentially, that inflation period may have ended at different times in different places. So, there could literally be these little pocket universes that formed when inflation stopped at these different places that could, for all practical purposes, be completely separate and could never, communicate with each other. So, they might as well be in another space-time kind of thing. So, and yet they originated from the same thing. So, I don't know, it's kind of hard to know, in what way you could escape space-time, kind of like what Michio was talking about. Is it just creating your own little segment, or going in a different dimension, or who knows what, right?
I think that I think we were on the right track earlier. I mean, it's already known that space-time is malleable, at least to a certain degree.
Right.
And that's just under natural conditions. Granted, black holes are some pretty extreme natural conditions. But given enough time, it's possible that we could artificially create conditions that are much more intense or severe in some way, in such ways that we could shape the very universe around us at whim. I mean, that particular concept doesn't necessarily. I mean, that doesn't strike me as impossible. I just think that it's highly improbable that anything would ever get to that point. I don't know.
Right. We're much more likely to destroy each other way before we have the knowledge to be able to do anything like that.
I mean, honestly, who knows? Maybe it's really not all that crazy complicated. I mean, there were people, for example, that thought, and I admit, although I was very young, so you got to, cut me some slack here. But when I was pretty young, I was convinced that when they started the Large Hadron Collider, that it was going to make these little black holes. My stepdad got me buying that left and right. And the concept behind that was relatively simple, right? They thought they were going to make these little micro black holes that would, suck up everything. And, if you don't know anything about anything, that kind of makes sense. But my point here with this is to say that I was convinced that these little micro black holes were going to consume the Earth, and it's these concepts weren't that complicated, and it actually had some people relatively convinced. People who are actually intelligent enough to know better. So that kind of gets me thinking that maybe some of these things aren't as impossible as it might seem. I mean, who knows? Maybe it wouldn't be all that crazy to be able to make a black hole. I mean, I know that there are people out there right now who can create engines if they had the capacity to make black holes. So, I mean, the capacity to create little black holes would be extremely useful. So I think that somebody might actually figure that out, and sooner than we think. But even still, putting that into scale, we're talking about shaping the universe. And like I said, what would need to be necessary for that, I would think, I would imagine, is something far more intense than just a giant black hole or something like that. I mean, who knows? I could be.
Well, maybe maybe we make a circle of black holes to shield us from the rest of the expansion of the universe. Haha.
That'd be interesting.
Totally crazy. No, but one thing to note though, with the micro black holes, people were worried about that, and you can still find on the internet, a lot of people talking about this kind of stuff. But scientists aren't that reckless, like if they thought for a second that there was any chance that something like that could happen, it would swallow the Earth, and they would never do it. No scientist would ever sign up for an experiment where they thought that there was even a 1 in a billion chance that something like that could happen. Scientists understand how particles work at these energy levels, and nothing like that could happen.
Well, and that's actually what they did, because I think I do remember seeing a number that was like 1 in a million or 1 in a billion or something, and that was the scientists acknowledging that was indeed a possible outcome. However, it also requires an understanding of particle physics and quantum physics at that level, which is to say that the moment that they create the black hole would then immediately evaporate because it's not able to take in enough mass to sustain itself, and it quickly disappears. Right, so they acknowledge the problem. It's just the problem fixes itself, so it's not a problem.
Yeah, and that's really what I meant. I just didn't go into details, but yeah, that's a great for explanation. And if you think about it, in our upper atmosphere, there's particle collisions that happen from particles that are emitted by the sun and hit our atmosphere. The energy is far greater than what the Large Hadron Collider can create. So when you look at the aurora borealis, those energy collisions that produce that light are many, many times higher energies than what the LHC creates. So, scientists know not to do anything stupid like that.
But no, that does bring up a good point as far as what does the end of the universe look like and what's going to cause it, whether it's going to be, quote, natural causes, or if there's going to be some sort of influence by organic biologicals like us, or if it's going to be something that we, maintain and gain full dominance over. We are still a few steps behind gaining dominance just over the environment of our planet, but you can certainly upscale that to the level of the universe and see that, well, maybe with enough time and enough technology, we can certainly reach the point that you're proposing, in which we can manipulate the universe in ways to attain our own goals. Now, I'm going to just go off on a tangent here real quick, because this was just sent to me today, which is awfully ironic, I think. But as far as our influence on the universe and the universe's influence on us, it is a particular importance to consider the interaction between us as human beings and other alien life forms that we may or may not ever come in contact with. So I find it particularly interesting that even when considering the scale of the universe, the end of the universe may come sooner than expected, just like the end of this planet may come sooner than expected through us warring with ourselves, with other biologicals. So when we think about the end of the universe, we can, imagine a scenario where we end up at a level where we have interstellar travel, interstellar manipulation, and we end up at war with another alien species that also has that capability. So you're almost thinking of using an atomic bomb at a universe kind of scale. And that can certainly, that can certainly rip apart the fabric of space-time that holds everything together, and then we all die.
Yeah, I mean, when you think about it, the human species as a species has only existed for 200,000 years. The universe has existed for 13.7 billion years. And, it was only I think it was in the millions of years, like hundreds of millions after the Big Bang that, stars formed. And I think it was some number of couple billion years when stars with planets could have formed. So potentially there could have been life that existed for way longer than life has existed on Earth, in another place in the galaxy. I mean, so there could be life, intelligent life that's far, far more advanced than we are. And, we're, much more likely to be in the losing end of such battle than we are to be on the winning end of such battle. So,
but that's exactly why I'm bringing this up. This link that I was just provided with today.
Yeah.
It turns out that NASA was hiring a planetary protection officer.
I heard about that.
Yeah, whose job is to prevent alien contamination to this planet from NASA space missions. So once again, that's just getting to that idea that we can be involved in some sort of war with some sort of alien race, and it can definitely influence the outcome of this universe one way or the other.
Do you think they'd consider knowledge of their existence contamination? What do you think? Let's get conspiracy theory mode for a second.
Yeah, no, it's more just preventing an alien. What was that one movie? There was a space movie that involved finding an organism. I think it was on the moon or on Mars, and it ended up like killing most of the crew. Anybody know what I'm talking about?
Was it Eureka?
Yeah, I know the movie. I don't remember the name.
Yeah, okay. It was something like that, I think. I can't remember. But yeah, no, that's a real scenario to think about. It's
when scientists send probes to Mars, for example, they sterilize the Mars rovers, like Spirit, Opportunity, the little Sojourner that we sent before that, like all those have been completely sterilized before they left Earth, so that we don't contaminate other places.
But at the same time, now people are still one thing that I thought was kind of interesting was I heard this conversation. It was like this televised event. I don't even remember what it was for, but it was this lady that was having a conversation with these people that I think it's Planet X or something like that. SpaceX, that's what it is. SpaceX is trying to send a group of people to Mars here in the near future. And, they're talking about all of these intense measures that they're taking to prevent contamination. And these people are saying, well, isn't that the point? Isn't that why you're going there, to colonize the place? Like, why are you this? I mean, because some of these people are saying that some of their measures were just a little much and a huge waste of money. But, that particular point kind of stuck with me a little bit. It's like, that's a solid point. I mean, they're talking about colonizing that planet. I don't know how much more of a contamination you can make.
Yeah, I mean, certainly if you send people there, you're going to contaminate the heck out of that place.
Well, the issue mainly comes down to our search for alien life forms, right? So That's where most of the worry is that we're going to contaminate the results of our own experiments looking for life forms. So that's where most of the concern comes from. Honestly, my concern comes more from a conspiracy theory type angle, just because I love the alien movies. And I'm kind of terrified of seeing the interaction between something that we accidentally introduce or contaminate into another organism's environment, and seeing that we actually exacerbate our problems by introducing that foreign element. So, let's say we bring the Ebola virus with us to visit Mars, and there's an organism there that takes the Ebola virus and assimilates it into their own genetic code and uses it as a weapon against us. A very, very, very effective weapon. That's another concern that I have.
No, I agree. That's honestly I kind of always had this War of the Worlds type concern, like what you're talking about. I think that one of the biggest concerns that we would have if we're talking about interstellar communication, no less interaction, is this biological one. Who knows how incompatible our natures would be, and the things that exist within us. Like we had a conversation not so long ago where you had said we are essentially nothing but a bunch of bacteria held together by a sack of skin. And that alone, it's inevitable. We have to take this stuff with us, and they have to take theirs with them. I mean, that's a legitimate concern to me. And I think that might be the big issue that would keep these interstellar beings apart, including ourselves. I agree. That's interesting to think about, though.
So there's something out there called the Fermi paradox. So it basically, Fermi, who is Enrico Fermi, I think he died in the 50s. He posed the following problem to some of his colleagues. There's 100, 200 billion stars in the Milky Way. A lot more in the observable universe. And his point was, if a civilization was to move at some slow speeds, speeds that are easily attainable by, not by us, but are not impossible to attain given the laws of physics, it will only take something like 50 to 50 million years to colonize the entire galaxy. So if you imagine, like, we send a probe with some people to a star that's a few light years away from us, say Alpha Centauri. They settle there and send 2 more probes to somewhere else, and we send a couple more probes, and so it's this geometric expansion. And even at quote-unquote slow speeds, it shouldn't take more than 50 million years to colonize the entire galaxy. So Fermi, was wondering, why isn't the galaxy colonized? And there was some explanations that they gave, do civilizations go extinct after a while? Do cosmic events tend to annihilate intelligent life, or all kinds of other questions? But I thought that was kind of an interesting paradox that those guys brought up.
Well, I don't know. Maybe I think, it makes sense. It's possible that it's extremely rare for a species to get even to where we are. And I think that we are already to a point where if we were to use up all of our coal, all of our fossil fuels, all of our chemical energies, even if we were stuck with nothing but the plants we can grow from the earth, the wind, the tides, and the sun, we could still make it and make it pretty well, I think. I think that's a huge step. I honestly, like Michio Kaku likes to talk about, you were describing them earlier, like type 1 civilizations through, like, what is it, type 4 or 5?
Yeah.
And I think that it kind of undermines a little bit the importance of the steps that we're already making. Like, I think that's it's incredible. The fact just to think about what we're capable of, should push come to shove, especially.
Yeah, I mean, a lot of people like Elon Musk and like all these other people are talking about that. If we want to preserve humanity, should become at least a two-planet species. That's why they want to colonize Mars. I think that's kind of nuts, but.
Oh yeah, wouldn't that be type 1 though? I thought that Michikaku was talking about.
It would get us closer. It would get us closer to type 1. Yeah.
I don't know. I can't imagine right now us being able to completely terraform Mars, for say, to the extent where people can just be outside.
Right.
I don't think that something like that would be possible for thousands of years, perhaps.
Yeah, it's probably more in the hundreds of thousands of years of time scale that we can actually, in fact, terraform Mars to the point where you could walk outside and without any kind of breathing apparatus or whatever.
Especially if you actually consult some of the people in modern day USA and ask them if we are having any impact on the environment, they're going to tell you no. So according to them, we can't even remotely terraform this planet, much less another planet later on down the line, which is of course lunacy and goes towards the whole global warming is a hoax crap. So
it's scary how prevalent that is too. I have these conversations with my wife all the time. I hate it. I run into it almost on a daily basis. Granted, I'm putting myself out there to receive this. I'm actively searching for this stuff, but I'm sick of seeing it now. I'm kind of to a point where I'm just I don't know. I don't know what else to do but what I'm already doing. So I just got to keep fighting a good fight, brothers. Just put it out there. Global warming is a real thing.
Yeah, science denial is a very big problem, especially in the United States. I mean, other countries are not nearly as bad when it comes to denying, obvious science like global warming. We are affecting the weather on planetary scale or climate, planetary scale, and we're warming things up. And just like we're doing it here, we could potentially do it on Mars. But there's other challenges there because Mars doesn't have the magnetic field, which allows the atmosphere to be blown away, which then means that we can't really create this kind of warming effect that we have here, and so it's going to be more difficult, but not impossible.
Yeah. Well, and maybe I'm underestimating things here because we're trying to put things into perspective. We're talking about the end of the universe. And Michikaku has a point here for this type 1 thing, I think, come to think of it. Because as Chris had said, I'm sorry, it was UV, had said earlier, the sun will eventually expand to a point where Mars and Earth aren't going to be around anymore. They will have been absorbed into the sun. So we will have to find a way to not only colonize a neighboring planet as a good practice run, but we got to figure out ways to colonize other star systems if we want to survive immortally as a single lineage, which I think it ultimately is our goal. I don't know what else to really do as a living thing. Like the whole point of everything that I do is to make sure that we flourish as a species, to continue going, to keep on keeping on, and, ultimately it's going to be hopefully it'll be our future descendants, whatever they might be, that figure this stuff out. I honestly think that we'll be getting information on other stars. Probably, if we're really lucky, I might get to see pictures of another planet from another star before I die, if I'm exceptionally lucky. There are programs in the running right now that are trying to send probes to, I believe it's Alpha Centauri, our nearest neighbor. And some of these programs are expected to launch within a decade. And it's supposed to take something like 40 years to get there. And then it'll take like 2.5 years for the information that it picks up to get here. So in theory, if I live long enough, which I think I might, I should be able to get to see the first photos of another planet from another star system. And I think that would be incredible. That would be so cool.
That would be pretty awesome if we could do that. I think we're more likely, though, to see at least some glimpses of other planets just by building bigger and bigger telescopes, just straight up optical or infrared telescopes. We already have some telescopes in orbit that can detect planets around other stars, but they do it by observing the stars and the light and how the light changes and how the brightness changes, and based on, how periodic those changes in light are and how much the light dims and all that, they can figure out how big a planet is that's around this star. They can maybe get a little bit of information about the makeup of the atmosphere, if it has an atmosphere, just by looking at some of the wavelengths and how they change. So we can kind of sort of do a little bit of that. And if we can block the star's light very precisely, we may be able to build a large enough telescope where we can actually take a picture from Earth of that planet. But
well, see, I think
the problem is the light of the star just, whitewashes the whole picture.
Yeah, obviously, yeah, you're right. It's like holding a lit match to a light bulb or whatever. It's going to be pretty hard to see the flame. But what you were just describing there is a huge engineering problem, because to the best of my knowledge, the only way to get more resolution is to make a bigger machine. And right now we already have a radio telescope of some sort that's essentially as big as the Earth. So we need to start working on scales that are larger than the Earth to get greater resolution, which would require us to put satellites into space that somehow geosynchronously orbit in such a way where they can focus on the same object.
Well, radio telescopes, though, can't really make you a clear picture like you think of a picture. In terms of something that, you can't just print the picture the radio telescope produces and look at it and say, oh, look at this pretty planet that we have. So you need more like something like the Hubble, like a giant version of the Hubble, or, Hubble works in the visible spectrum. So Hubble sees the same light that your eyes and my eyes see, but something in the infrared spectrum or the ultraviolet, or, some of those may be easier to build. And, they're currently, we're currently building like the James Webb Space Telescope and others that we're going to send up, and they have mirrors that are much, much bigger than the Hubble. But the cool thing is exactly what you said, Caleb. It's an engineering problem. And if it's an engineering problem, it means that it can be overcome. A physics problem is hard to overcome. An engineering problem usually just takes a ton of money, a ton of time, and the dedication of a team to do it.
Money. That's what it boils down to there. I agree. And well, it's basically, look how much money it took to build a Large Hadron Collider. Biggest thing ever made with human hands. And that thing is incredible. Absolutely incredible. And the discoveries that we've made from this thing are just, honestly, they've changed our perspective of the universe fundamentally. Oh yeah,
they've taught us, much more than we've ever known about the beginning of the universe and potentially how the universe is going to end. The information that we need to find out how the universe is going to end, we get a lot of it from cosmology, from looking at stars, from looking at galaxies, from looking at all that. But the physics on the small scale tell us a lot about how the universe began, and it's going to therefore inform how the universe has evolved since the beginning until now, and which means we're going to make better prediction about how the universe is going to end. It tells us about everything.
All right, guys. Well, on that note, we're going to go ahead and wrap it up. I thought this was a fantastic conversation. This was definitely one of the funnest conversations I've had on this show. I just want to thank you guys for listening. I want to thank you guys for hanging in there with me, and we'll see you guys next time.
Yeah, thanks for joining us. Bye, everyone.
See you.
That is all the time we have for you this week. This has been the Hoosier Humanist Hour. Be sure to check out FreeThought Fort Wayne on Facebook and on meetup.com. Thank you for listening, and we hope your days are filled with logic, reasoning, and the eternal quest for knowledge.